Okay, guys, yesterday in the classroom that we have discussed about how to configure the OSPF and what is the difference between the distance vector and the link state routing protocol, right? Now, quick question to all of you. दिखाई देता हूँ यार, एक quick question पूछूं. Okay. Sorry, no starting में. So this is my topology, right? And how many broadcast domain over there? Can anyone tell me how many broadcast domain over there and how many collision domain? जल्दी बता दो. How many broadcast domain over there? How many collision domain? R2, R3,
One.
huh? Five.
Five
Yeah.
broadcast domain.
Okay. And collision domain? Broadcast domain बताओ. How many broadcast? 5 broadcast domain out. 5 broadcast domain and collision domain. जल्दी बोलो. नहीं है. अरे गलती बोल लो यार. मुझे पता सही तो कि बोलना नहीं है किसी को. Tell me the wrong answer.
One broadcasting domain.
And collision.
Five collision.
गलत है. Yes, guys, we have 1 broadcast domain and 5 collision domain, and those have an answer like a 5 broadcast domain. Please, yaar, read the CC. Okay. Let's configure the EHRP right now. Router EHRP1 network 0.0.0.0. Router EHRP1 network 0.0. Copy कर लो कमान यहाँ से. Done. So if you see right now, R1, what happened if I'm going to run the EHRP, right? If I'm going to run the EHRP in this topology, how many neighborship you will have? An adjacency. You will have a 5 neighborship. Okay. And you will have a 5 adjacency. Sorry, 4 adjacency. R1 is going to maintain the 4 neighborship and 4 adjacency. Is it? If you go for the R5 router, see, R2, R3, and even R4. Try to understand basically what happening over there. Basically, R1 is going to maintain the 4 neighborship, R2 is going to maintain the 4 neighborship, R3 and 4 neighborship. So each router is going to maintain the 4 neighborship and 4 adjacency. Adjacency means what? We can share the route information directly. So in this case, what happened if in this case what happened if R1, right? If R1 will receive a 1 update 1.0.0.0.0, R1 will send this update to whom? This guy, this guy, this guy, and this guy. Directly, I'm not saying that indirectly, directly it will send the update to the each and every person because they have a 4 adjacency with the every person. Neighborship means what? We just know each other. That's it. Neighborship means what? We just know each other. But adjacency means what? We can share the route information directly. If R5 has a information 5.0.0.0.0.0, they can directly share this information of this person, this person, this person, this person. If R5 has a information 4.0.0.0.0, they can share this directly to this person, this person, this person, and this person. Even if you got an R3, R3 can share this update to the this person, this person, this person, and this person, and R2 also send this update to the this person, this person, this person, and this person. It's like a full maze. If you're forming the neighborship with the full mesh, no issue, right? If you're forming the neighborship with the full mesh, there is no issue. It's good because you have to, because neighborship should be maintained, right? But adjacency, every router is going to form the four adjacency over there. Is it possible? This is not a bad, this is totally a bad solution in this case. Every router is going to increase the load. It is something like that. This is the classroom, and in this classroom, what happened? There is a 4 people sitting over there, right? And this guy name is A, this guy name is B, this guy name is C, this guy name is D, and this guy name is E. If the new person is coming in this classroom, what happened? Try to understand. This guy name is X, right? And if this new person is coming to the classroom, A must need to know about A. Sorry, X must need to know about A. X must need to know the B. X must need to know about the C. X must need to know about the D, and X must need to know about the E. So this guy has to form the neighborship and adjacency with the every person. This guy, if this guy wants to sit in this classroom, right? And in the classroom, what happened? Many information is exchanging, right? In the classroom, what happened? Many information is exchanging. For example, the if the trainer is going to tell you, right, tomorrow is holiday, then how you will get the information? You will get the information from the students, right? But in this case, what happened? If you want to get the information, you have to form the neighborship adjacency with the every person, right? That is not a feasible solution. So in this, to avoid this problem, what we can introduce over there. So just take example, if this classroom has a thousands of the people, this person has to manage, has to maintain the thousands of the student information. So to avoid this problem, what we can do over there, we can simply say that, okay, you are the monitor of this classroom, class representative, right? You are the monitor of this classroom, class representative. So now if the monitor is the classroom of the class representative, what happened? If every person is coming in the classroom, this guy is going to form the adjacency with the CR only to get the information, because CR is a person in the classroom. Those have a complete information about the class. If something is happening in the school, if something is happening in the class, they know each and everything. So in this case, what happened? X is not going to form the adjacency with every person. Yeah, they can form the neighborship. They can form the neighborship with every person, but adjacency I can only form with the CR. Same thing what I can do in the OSPF network, guys. In this domain, what happened in this classroom, in this one broadcast domain, what I can do over there, I'm going to elect a one router I'm going to elect a one router as a CR, class representative, and one router as a backup CR. Because if the CR is not available, I need to maintain the information of the CR, right? If the CR is not available, I need to maintain the information of the CR. So we need to introduce the backup CR as well as. Now what happened? Every router, whatever the routers you have in this network, previously what happened in the EIGRP case? In this EIGRP case, router 1 is going to form the neighborship with the R2, R3, R4, and R5. At the same time, they are going to form the adjacency with the R2, R3, and R4, and R5. Same thing with that router number 2, router number 3, router number 4, and even router number 5. But now, after enabling the OSPF, I'm going to enable the OSPF in this case. What OSPF is going to do? OSPF is going to find the CR of this broadcast domain. And every router forms the adjacency with CR and backup CR only. But neighborship, of course, complete. It is something like that. If R1, if I'm going to enable the OSPF on this guy, this guy, this guy, this guy, and this guy, and I have declared that R5 will become the CR of this classroom, and our backup CR is R4, what happened? Every router is going to form the adjacency with CR only and backup CR. Because adjacency means what? I can exchange the route information. Previously, what happened in the EIGRP case? In the EIGRP, what happened? You're increasing the load on this guy. Every router. How many routers we are going to form? If you have thousands of the people in the classroom, every 999 people's, right, is going to form the neighborship with the CR only. And what CR is going to do in this broadcast domain? This guy is going to manage the domain. And backup CR is just wait, or we can say that it's just going to monitor the CR. Of course, adjacency I'm going to form with every person, right? R1 is going to form the adjacency with this R2. R1, sorry, neighborship. R1 is going to form the neighborship with the R2. R1 is going to form the neighborship with the R3. R1 is going to form the neighborship with the R4, and R1 is going to form the neighborship with the R5. Neighborship will we have a full. R1 is going to maintain the 4 neighborship, but adjacency they have only 2. So as compared to this one, this is good, right? This is almost same, right? 4 neighborship, but adjacency there's a 4, I have just 2. And this is the benefit of the OSPF. What OSPF is going to do in your one broadcast domain, in a single broadcast domain, this router is, so the OSPF router is going to elect the one CR and one backup CR before exchanging the update. Before exchanging the update, what happened? This guy is going to find the who is the CR and backup CR in my classroom. And that CR is known as a DR of the OSPF. And backup CR is known as a BDR of the OSPF, and the normal router will become the DRO. Those router will not become the DR and BDR. Automatically, they will become the DRO. DR means designated routers other. So DR means designated router and DRO means designated router other. And BDR means backup designated router. So every router, every DRO, right? Each DRO is going to maintain the neighborship. Each DRO, right? Each DRO is going to maintain the neighborship with the DR and BDR. And if they have an update, for example, if this guy got an update 1.0.0.0.0.0, what this guy will be do? R1 is a DRO, right? R1 will not share the information to the directly to the R2. They will not share directly information to the R3. They will just directly share this information to the DR and BDR. So we can simply say that DR equal to BDR. We have a neighborship and we have adjacency. DR equal to DRO. We have a neighborship and adjacency. BDR but DRO and DRO just neighborship. So how many types of student is present in the classroom? In this classroom, how many types of students are present? They are just assuming that these are the students, right? In this classroom, how many students are present? 5. And how many category of the student? There's 2 category of the student over there. One is a intelligent group. One is the intelligent group. And another is a non-intelligent group, right? Two groups are there, right? One is an intelligent group and one is a non-intelligent. Intelligent group has a DR and BDR. And non-intelligent group is going to contain the DRO. So if you have a 2 groups, then how we can identify each group? By using a multicast address. So if you have a 2 groups, then you have a 2 multicast address. As compared to the RIP and EHGRP, as compared to the RIP and EHGRP has a single, right? OSPF has a 2 because there is 2 types of people, non-intelligent and intelligent. So I can say that the intelligent group, the intelligent people is going to belong from the 224.0.0.0.0.6, and non-intelligent group, not non-intelligent, every person, right? Because this guy is coming in the non-intelligent as well as every person is going to belong from the 224.0.0.5. So DR and BDR, right? DR and BDR has a reserved multicast address 224.0.0.5, sorry 6, and all the OSPF order. Two to 4.0.0.5. Two types of people, two types of multicast address. One is a DR and BDR 224.0.6 and all OSPF order is 224.0.0.5. If you remember that, what is the use of network statement? It advertises the route, right?
Excuse me, sir.
Yes.
Sir, all the OSPF router means even the DR, BDR will
Yeah,
come.
exactly right. All those routers is DR and BDR. It join the multicast group.
Join the multi. To enable
And
the
third, so in this case, what I have tried to understand, if R1 is DRO, just take example. If R2 is DRO, if R3 is DRO, which multicast group they will join?
.5.
Right? Let's enable the OSPF on this person as well as. I'm going to enable the OSPF on this guy as well as enable the OSPF on this guy as well, right? Once I'm going to enable the OSPF on R4 and R5. And then once this guy will become the DR and BDR. Is it? So this interface, right? This interface will join the two group. One is a 5, and one is a 6. This interface will join the two group, but this interface will join the single group. How you are going to identify this person will become the CR of this classroom? How you can identify this person will become the CR of this classroom? Based on the knowledge, right? Based on the knowledge, I can say that A will become the CR of the classroom and B will become the backup CR of the classroom, right? Based on the knowledge. What is the knowledge of the OSPF router over there? Once you're going to enable the OSPF, right? Once you're going to enable the OSPF on this router, once I'm going to enable the OSPF on this router, what happened? This guy also has a knowledge, and that knowledge is known as a priority. Basically, the priority is a 8-bit number. You can define from 0 to 255. By default, the priority is 1. And this is the interface priority. So once I'm going to enable the OSPF on this interface, the priority will become the 1. 1, 1, 1, and 1. So what happened once I'm going to enable the OSPF on this router in this broadcast domain? What happened? First, this guy is going to find which one is the higher priority. Which one is the higher priority? By default, the priority is 1, right? If the priority get tied, then it will go for the which one is the higher router ID. So in this case, what happened? The priority get tied. Then it will look up for the who has a higher router ID. The router ID in this case, what happened? This guy has a router ID 101. This guy has a router ID 102. This guy has a router ID 113, and this guy has a router ID 104, and this guy has a router ID 105. Who will become the DR in this classroom? Priority get tied, right? By default, the priority is 1 on every interface. So once the priority get tied, then it will look up for the higher router ID. Which one has the higher router ID?
R5.
R5 has a higher router ID, right? अरे यार गलती हो गई. So R5 will become the DR and R4 will become the BDR of this classroom. Of this broadcast domain, R5 will become the DR and R4 will become the BDR, and automatically this guy will become the DRO, DRO, and DRO. Let's see this type of practical till this point, then we'll go for the much detail. So let's do one thing. I have a CLI access right now, and I can remove the EHRP from there. No dot EHRP1. And wait for some time. ओए रश्मि, मैंने तुझे कॉल किया था. एक बंदे का वो करवा, एक बंदे प्रॉब्लम था, उसका लैपटॉप में वो इंस्टॉल ही नहीं हो रहा था GNS3. उसका भी मैक था. वो लोग भी अमीर लोग थे तेरे जैसे, बहुत अमीर है वो भी तेरे जैसे, तो उसका भी करवाना था.
मुझे
क्या?
कॉल करे, मेरा नंबर दे दो उसको.
हाँ, मैंने इसको तेरा नंबर दिया था, उसने कॉल नहीं किया क्या?
नहीं, किसी ने कॉल नहीं किया.
तो तूने मुझे 2 कॉल क्यों किया था दिन में?
वो
बस
इंटरव्यू
बस
के
बस
लिए.
बस बस बस. इंटरव्यू
हाँ.
फेल हो गया?
नहीं, HP में आया एक रिक्वायरमेंट, इसीलिए.
मुझे भी ले चल साथ में.
पैकेज कम है, आपका पैकेज लेवल का
अरे भाई, साथ साथ करेंगे काम.
आपके लेवल
पैकेज
का
नहीं,
पैकेज
नहीं,
बहुत कम है.
कुछ चीजें पैकेज के लिए भी नहीं होती है, अदर चीज के लिए भी होती है. So guys, have a look over there. What's happening? Try to understand. Try to analyze the previous debug as this message. Once I'm enable the EHRP, you will get the form message, right, on R1 router. But right now, if you see OSPF, so in this case, well, let's find who has a DR in this broadcast domain right now. So if you go, so IP OSPF, right, neighbor, what is saying that my DR is 105. R1 is saying that this thing, right? My BDR is 104. And what is the default priority of this interface? So if the priority get tied, then what I'm going to look up? I'm going to look up for the higher router ID. And if you go for the R5, this guy has a higher router ID 105, right? And R4 has a 104. So R5 will become the DR of this classroom, and R4 will become the BDR, right? DR, BDR, DR, DR, DR. Because of the high router ID, because of the priority get tied, by default the priority is 1, right? By default the priority is 1, and if the priority get tied, I will become the DR router high router ID. And high router ID, R5 is a high router ID, and R4 is a lower router ID as compared to the R5. And this guy will be in the DRO, right? So if you go on R1 right now, again, and see one thing, show IP OSPF interface 0/0. This is my address 101. This fast Ethernet 0/0 is up with the OSPF. Line protocol is up, and internet address is 101.1.8, and this this interface is belong from area number 0. The process ID I'm using right now 1. That you have a 16-bit of number, you can take any number. The router ID of this person is 101. Network type is broadcast by default on a Ethernet interface. On a Ethernet interface by default, the network type is broadcast. So you will have a broadcast by default on Ethernet technology. Second, we have a non-broadcast, that's known as the NBMA network, non-broadcast multi-access. Then we have a point-to-point network. Then we have a point-to-multipoint network. These are the 4 network types you will have in the OSPF. One is the broadcast, non-broadcast, point-to-point, point-to-point. Right now I'm discussing with the broadcast, right? In the broadcast, what happened by default? On every Ethernet interface, Ethernet means what? Either you have a fast Ethernet, 100 fast Ethernet, 100 Mbps, 1000 Mbps, gig Ethernet, any Ethernet that belongs to the Ethernet family. All they are enabled with the by default broadcast capability. These are the OSPF network types. So we'll see that OSPF network type is a broadcast, and in the broadcast network, right, you will have a DR and BDR concept. So right now I'm discussing about the only broadcast, so I'm not going to include any information of this concept, right? Forget this one right now. So in the broadcast network, what happened? You will have a DR and BDR. So if you see this person right now, I have a DR. The state is DR right now. Of course, R1 is a DRO, and R5 and R4 will be on the DR and BDR. R5 is BDR, sorry, DR, and R4 will be on the BDR. So this interface is saying that, okay, I have enabled with the OSPF, my network type is a broadcast. The cost of this interface is 10, right? And the default interface cost is of the fast Ethernet is 10. The enable interface, so we can see that the DR IP address is 105. My state, right? R1 state is this saying that my interface R1 state DRO. I'm the DRO of this interface, and my priority is by default 1. DR is 105, and backup DR is 104. This is the hello time and date time, right? The 10-second and 40-second. Like EHRP, we have a hello time and hold on time. So in the OSPF, we have a hello time and the date interval, 10-second and 40-second. So if I'm not able to receive at every 10-second, what happened? Router will continuously send the hello packet. So if router will not receive any hello packet till 40-second, it will break the neighborship. And right now, what happened if you go on R1 router? What R1 is saying that neighbor count is 4. Neighbor count is 4. So right now, R1 is forming the neighborship with this guy, this guy, this guy, and this guy. Neighbor count is 4, but adjacency count 2. And I'm forming the adjacency with the neighbor with the 1.4 and 1.5. That is, so right now, R1 is going to form the adjacency with this person and this person. And in the adjacency state, we are going to exchange the update. So if R1 has received some update 2.0.0.0 network, what R1 can do over there, R1 will directly save this information to the R5 and R4. They will never share directly. They cannot exchange the direct information to the R2 and R3. They cannot share because these are the DRO, and DRO only form the neighborship. And DRO with DR, you will have a neighborship and adjacency. DRO and BDR, you will have a neighborship and adjacency.
Excuse me, sir.
Hmm.
Sir, in just this thing, neighborship, then what's the use of neighborship, sir? If they can't exchange roads?
Sorry?
In adjacency only they can exchange the road information, no, sir?
Right. Only.
What's the use of neighborship, sir?
Neighborship means what? अरे यार, कई बार पढ़ा हूँ तुमको. So Anup is belong from the UK. Vinay is belong from the USA. दोनों में जाना नहीं है कहीं. ऐसे मैंने लिख दिया. So Anup is belong from the UK and Vinay is belong from the USA, and both are meeting on the Dubai airport. Right? In Dubai, Vinay has one newspaper, that's TUI. Just take example. They have any magazines over there. So Vinay has some magazine. So what Anup is going to do? Anup is going to first they will introduce itself. Hey, Vinay, say, hey, hi, how are you? This is Vinay, right? Sorry, this is Anup. Right? This message that Anup will be sent to the Vinay. If Vinay is interested, try to understand. If Vinay is interested, then Vinay is going to say, okay, hi, I'm good. This is Vinay. If this information will be exchanged, right? This is just information about your what? About your name. That's it. Identification. This is just your identification. Right now, R1 show IP OSPF neighbor. R1 router is forming the neighborship with the 1.2, 1.3. Just identification. Just identification. This person are present in my broadcast domain. R1 is identify this person and this person is present in my broadcast domain. Now, this is known as a neighborship. That means I have a information about you, right? I have a information about you. This guy is saying that I have a information about you. This is a neighborship. Only the identification information. Now what happened? Now Anup is going to say that, hey, can you exchange your magazine? Now the Anup is saying to the Binay, hey, can you exchange your magazine after the neighborship has completed, right? Now Anup is asking to the Binay, hey, can you exchange the magazine with me? Now Binay is giving the magazine to the Anup. This is, we are exchanging the information. This is known as a adjacency. So R1 is going to form the neighborship with the R2 to identify how many persons are present. They are also going to form the neighborship with the R4. As I told you that Vinay is going to form the, Anup is going to form the neighborship with the Vinay, right? At the first time. So identify how many persons are present in my broadcast domain. Once we identify how many persons are present in the broadcast domain, now what R1 is going to do? R1 is going to find who has a DR. So DR is R5 and BDR is R4. Now this guy is going to form the adjacency with the DR and adjacency with the BDR. They are not going to form any adjacency with the R2 and R3. But in the EHGRP case, what happened? In the EHGRP case, R1 is forming the neighborship with the R2 at the same time adjacency. That is not a good thing. You are making a full mesh topology over there, but this is not a full mesh. This is a partial mesh over there, right? I'm not going to form the neighborship with the every person, sorry, adjacency with the every person. I'm not going to increase the load. I'm just going to share if any update is coming to me. If any update is coming to me, I can only share this information to the DR and BDR, something like that. This is your classroom. In this classroom, what happened? Many questions are there, right? A, B, C, D, E, F, right? If some information, if for example, if some information is coming in the classroom that tomorrow is holiday, in this classroom, what happened? A is a CR, right? A is going to make an announcement. There's a holiday tomorrow, right? A is going to make an announcement. There is a holiday tomorrow. D cannot do that because D does not have a responsibility, right? D is not a CR. This is the non-intelligent people, right? This is just a normal student. So if any information is coming to in my broadcast domain, DR is going to share this information to every person. Same thing. Even if C got some information, right? C is normal student. C is normal student. C got some information. They cannot share the information directly to the DEF because they are not forming the adjacency. They can only share this information to the CR. And now CR will flood this information to the each and every person. So once the DRO, this is the DRO router, once the DRO will receive any information, they cannot share this information directly to this person and this person. They first share this information to the DR and BDR. And now the DR and BDR has a responsibility to flood this information to the every person. This is how your OSPF works. And this is how the difference between the adjacency and neighborship. Neighborship means what? They have a knowledge that how the person are present in my broadcast domain. Adjacency means what? I can save the update with you. Anup, clear?
Clear, sir.
Now, if you see that what happened, R1 is forming the neighborship right now. R1 is forming the neighborship with every person, right? They have a 4 neighbor. But adjacency, I'm only going to form with the DR and BDR. So as I told you that we have a knowledge in this one, the knowledge is known as a priority, the priority by default one. Then once the priority get tied, then it will go for the higher router ID, right? And priority you can define from 8-bit number 0 to 255. Now, once we have made the election, let's do one thing. Let me add one more router. And what I can do over there in this section, I'm going to configure the R6 router console. interface 0/0 IP OSPF. Let me increase the priority. IP OSPF priority, you can define the priority from 8-bit range 0 to 255. If you define the 0, 0 is the special priority, right? 0 is the special priority. If you define the 0, this interface, right? This interface will never participate in DR and BDR. Never. Doesn't matter they have a higher route ID. Doesn't matter if you define the, because priority first comes, right? Priority first comes, then it comes to the route ID. So the first is the priority, then is the route ID. If the priority is 0 over there, router will never participate into the election of DR and BDR. And 255 is a higher priority that is going to represent that this router always will become the DR. This router always will become the DR, right? So if you define the any priority, let's take an example of 100. Okay, IP OSPF 1 area 0. Tell me, I have defined the right now in this domain. Right now in this domain, what happened? This guy is a DR right now. This guy is a BDR, and this guy is the priority is 255. Sorry, 100 is defined, right? Tell me, will R6 will become the DR right now or not? Okay, before give this answer, give me this answer. I love my India. I love my India. This is Modi ji, right? Or the Prime Minister of this country. What happened? Some guy is coming and he's saying that I want to become the Prime Minister. Is it possible after the election? After the election, if some guy is coming and he's saying that I want to be just like Anup is coming, I would say that I want to become the Prime Minister of this country. Is it possible? Doesn't matter. They have a good knowledge, uncertain knowledge. They have a ultimate knowledge. But is it possible that after the election, the Anup will become the Prime Minister of this country? अरे हाँ ना तो बोल लो.
No, sir. Again,
No,
real.
right? It's not possible. So guys, once the election has completed, right? Once the election has completed of the DR and BDR in this broadcast domain, right? Once the election has completed in this domain, DR and BDR, and if another router is coming and that has a priority is 100 and he's saying that I want to become the DR, it's not possible. You are late. Because the election timer is 40 seconds. That is known as a wait timer. And you cannot change. Yeah. Once you change your hold on time, then automatically weight will be changed. So right now, I'll just take example what I will do. For example, I have start the OSPF process. I have configured the OSPF process. I put the command IP OSPF 1 area 0, 10 seconds. Right? In this broadcast 1.0.0.0/8. I put the command IP OSPF 1 area 0. It will require the 20 second over there. So 10 second more it was completed. Then IP OSPF 1 area 0, 35 second, and IP OSPF 1 area 0. It will take the 40 second. And now I happen to get the IP OSPF 1 area 0 in the 41 second. Do you know who will participate in the election of DR and BDR? Only this person will participate. This guy, this guy, this guy, and this guy. Yeah, this guy. Because you have configured, right, the 40 second, right? The election timer. So whatever the router that has configured within a 40 second, right? Whatever the router that has configured within a 40 second, they will participate in the election of DR and BDR. If the person is coming after just 41 second, right? 40 second, like a 41 second, and he's saying that my priority is 255, even you will not participate, right? You will become a DRO. After 40 seconds, if any person is coming, they will never participate in the DR and BDR election. Let's have a look over there. Right now, the R6 is coming after the 40 second, right? R6 has right now just came, right? And if you see R6 right now, even the R6 has a higher priority. This guy has a higher priority, right? Priority is 100. Other one is just a 1. Other person just 1, right? R1, R2, R3, just 1. R4, R5, just 1. But R6 has a higher priority. But still this guy is saying my state is DRO because I'm coming after the 40 second. The 40 second is a wait timer that is going to represent that it's a DR and BDR election timer. If the person is coming after the 40 second, you will not never participate in the DR and BDR election. And as I told you that there's no command to change the wait timer, right? There's no command to change the wait timer. If you're going to change the, for example, as the interface 0/0 IP OSPF hold on time, IP hold on time, and as interval. I'm going to say 100 second, right? Do show IP OSPF interface 0/0. Let me remove this person. Otherwise, you should do it wrong. So once I change the date time interval, automatically what happened? Your weight will be changed. So weight is totally this guy is totally relying on the date timer. This person is totally relying on the date time. If the date timer is 40 seconds by default, the weight will be also 40 seconds. And this guy is just going to tell you what is the election timer. That is a 40 seconds by default. Let me show you one more time. Let's do one thing. Interface 0/0. Done. Done, right? So I have disabled the OSPF for every person, right? Let's do one thing. Let me enable the OSPF on R1. IP OSPF 1 area 0. And I'm not going to configure any router as OSPF, right? R2, R3, I'm not going to configure any router as OSPF. Let's see. IP OSPF 1 area 0, do so IP OSPF interface. Brief. He said, oh, wait a minute, just wait a minute, because I need to wait for the 40 seconds before I'm going to declare. Before I'm going to declare, should I become the DR and BDR? What is saying that the state is waiting. I don't have a DR and BDR. It should be a state should be a DR and BDR, right? Or DRO. He's saying the state is waiting. He's saying now just wait for the 40 seconds. Okay, then after I declare who will become the DR and BDR. Once the 40 seconds has completed, this state will be changed. Let's see, do show IP interface brief. And now he's saying that I'm the DR. Previously, the state was waiting because I'm going to select the who will be the DR and BDR. Timer is happening, right? 23 seconds is, just wait for the 23 second, and then I'll, because that's a 40 second by default. Once the 40 second has completed, now this declared I'm the DR of this domain. And now let's do one thing. Let's configure the OSPF on every person by. Now I'm going to configure the OSPF on every person. Copy. R5, R2, R3, R4, R6. So already this guy become the DR. Now tell me who will become the BDR. Now I have enabled the OSPF on every person. So if you see any person, just go to R2, do show IP OSPF interface 0/0. Okay, timer has completed. Now tell me who will become the DR and BDR in this domain now. Sorry, BDR, because DR already elected. So who will become the BDR? This guy has a priority, has 100.
R6 will be BDR.
R6 will be BDR, right? Anup, कहाँ गया?
हाँ sir.
और कौन बनेगा DRO? Who will become the DR in this domain?
Remaining 4.
Good. चलो. समझ में आ गया खेला. So if you go on R1 right now, so see, do show IP OSPF neighbor. Of course, I'm a DR, so I don't have any own information, right? Who is the BDR? अरे 1.5 कैसे बन गया BDR? Possibly नहीं है. कैसे बन गया ये? यही बन गया ये DR. ये लेट आया था क्या ये? It's not possible. Let me disable one more time. It's not possible. Tinker chicken, tinker chicken, tinker chicken, tinker chicken. इसको तो पता ही नहीं कौन डीआर है कौन बीडीआर है. One broadcast domain, one DR, one BDR, rest of the router DR. यही बन गया ये. Now आया ना सही आप सही दिया information. Now it's good. Okay, R6 because they have a higher priority, right? Clear? Now let's do one thing. Capture this link. And capture this link. Is it something like this, right? Now tell me one thing. If R4 will receive any information, right? If R4 will receive any information, for example, let's do one thing. Interface 0/0, interface loopback number 1. Right? Link is advertised. Perfect. So if I'm going to advertise this link, interface loopback number 1, IP host of 1 area 0, how the packet look like this? R4 has the information 4.0.0.0.0. R4 is a DRO. R4 will create a packet. Source IP address 1.4. Destination R4 is going to send this information to whom? This multicast address. .6, right? Because R4 DRO is there, DRO can only exchange the information with the DR and BDR. That's the adjacency, right? If you go on R4, R4 is forming the adjacency with whom? 101 and 106. So R4 will receive any information, it will share this information to the 101, that is the DR, and 106, that is the BDR, right? And this information 4.0.0.0.0, right? Once R1 will receive this information, what R1 is going to do? It will change the source 101 and flood this information to whom?
05.
Is it? चलो देखते हैं. हो गया? अरे stop. अरे stop. So this is the capture of R4 0/0, and R4 will send the update packet. Yeah, 14. Source is 14 dot destination 0.06, right? This is a DR and BDR. Same information, and let's separate if you see. Four or four, right? So if this guy is going to send this update, source is a 104, R4 will send this update to whom? .6 DR and BDR. Once the DR will receive this information, right? 101. Now it will just replicate this packet, just change the source over there, 101, and destination will be .6 now. R4 will create the packet. It will send on a DR address. When R1 will receive the packet, because R1 is a DR, what R1 is going to do, it will send this packet to all the multicast address. देख लो यार, R1 के पास भी आया होगा पैकेट. ये R1 है. So if you see, ये रहा ना, R1 जो जनरेट करा पैकेट, ये रहा 112.0.0.5, right? This one. So whenever the DRO, right, whenever the DRO will receive the information, it will flood this information to the DR multicast address. This is how your information will be exchanged. Coming packet sent to the BDR and DRO. Sorry, DR. And now the DR will flood this information to every person. Now, quick question. Area 0, area 0. The priority of this interface 255, not 255. The priority of this interface is 255. How many broadcast domain over there?
2.
2, sir.
Who will become the DR and BDR?
.2 and
23.2 is the DR.
23.2 will become the DR, right? Because its priority is 255 higher. And in this broadcast domain,
12.2.
12.2.
12.2, sir.
okay, let's create a one more router, R4, and this interface 0/2 2, right? This interface 0/2. This guy is also priority 255. Who will be on the DR in this broadcast domain?
Sir, IP address.
Of this interface, right? Right now, this interface.
Yes, sir.
So what do you understand from this thing? The simple thing is that in DR is the properties of interface, not to the router. DR is the properties of interface, not to the router. A router can have a multiple DR and BDR. Clear? A single router, the R2 is become the DR for this domain, R2 is become the DR for this domain, and R2 is become the DR for this domain. Can become right. Clear? एक चीज और, priority 0, priority 255. Who will become the DR?
Sir, 2, router 2, 12.2.
And what about the R1? 0/0. It will move in the DRO, right?
DR.
If you go on R5 or R1 router, as I told you that R1, there's a 2 multicast address. So R1 is a DRO, sorry, normal student as well as intelligent student, right? So IP interface 0/0. They have joined the 2 multicast group. R1 is a DR. They have joined the 2 multicast group because it's a DR and normal student as well as DRO as well as. If you go for the R2 router, R2 will join the single group. Clear what?
Yes, sir.
Okay. One more thing. Who will be in the DR and BDR?
12.1.
12.2.
12.2.
तुझको प्यार जुटाऊं रे टिंग चिका टिंग चिका बस बस something wait for some time. Never complete. Also I change. Show IP OSPF interface serial 3/0. क्या बता रहा है? State point to point. Serial link behave like a point to point network. Serial link behave like a point to point network. And do we have any DR and BDR? No. We have a neighborship and adjacency over there, but there is no DR and BDR concept. On a serial link, on a point to point network, not a serial link, on a point to point network. By default, serial link will behave like a point to point. By default, this is the behavior. Even you can change the network type on a Ethernet technology, right? On this technology, even through IP OSPF, on this technology. Network type is broadcast, right? This is the Ethernet technology. This is the Ethernet technology, and this Ethernet technology by default the type is broadcast. You can change this thing as well as network type. Interface 0/0 IP OSPF network type. You can define the point to point as well as. But by default, it is a broadcast. And on the broadcast network, we have a DR and BDR. On the point to point network, we don't have a DR and BDR concept. That's why we don't have any DR and BDR. Doesn't matter. They have a higher priority. If you check on R7, let's do one thing. Interface S3/0, IP OSPF priority. IP OSPF priority 255, right? Priority is configured. अच्छा मैंने header discuss नहीं किया, कल discuss करेंगे. So what happened? R1 is in the priority field, right? In the packet, hello packet, but still there's no DR and BDR concept. I've configured this. If you check the show IP OSPF interface, that's not AR BDR. चले हो गया. So this is the most important interview questions, guys. What happened? They will give you this kind of topology, right? And they will ask you who will become the DR and BDR. Even they will configure the priority on this guy. Guys, on a point-to-point network, there's no DR and BDR. Even this is the Ethernet interface, right? And this is the broadcast. In this concept, what happens is a DR and BDR. Do one thing: configure every interface as a point-to-point. You will not have a DR and BDR. On a point-to-point network, there is no DR and BDR concept. On this network type, no DR and BDR concept.
Excuse me, sir.
हाँ पूछ ले तेरे से बोल.
Sir, one doubt in this wait timer, sir.
Okay, wait timer doubt. Wait timer is election timer.
The election timer. No, sir. Here we have 6 routers, sir. What in real time if we have 100 routers, how we can configure all that in within 40 seconds?
मेरे बाप. In a single broadcast domain, you have 100 router.
Oh, okay. Got it.
Order. Now,
But one doubt, sir. R6 you added after the election process, no, sir?
yeah.
I want to make R6 as only DR. Then
ले बना देते तेरे लिए और क्या चाहिए यार. चलो एक काम करते R6 को DR बना देते. Let's go na R6.
means I'll remove all the OS.
अरे ऐसे कैसे रिमूव करेगा तू, पागल है क्या तुम. So right now R6 has a 100 priority by default. You're not going to remove the process. You are just going to restart the OSPF process because no need to remove the configuration.
Okay.
How we can start? So, clear IP OSPF process. वेट कर लो, मिल जाएगा R6. No need to remove the configuration.
Okay, sir. In real time also we'll do the same thing, no, sir? We'll clear.
Yeah, same thing. Nothing is different.
Okay.
बन गया DR. अब BDR के लिए मर रहे होंगे सब एक दूसरे से. हो गया. तुम्हारा डीआर एंड बीडीआर, और कुछ नहीं बचा हुआ है डीआर बीडीआर में। प्रायोरिटी दिखाई दिया कैसे, हाउ टू चेंज द प्रायोरिटी, एंड प्रायोरिटी विल ट्रैवल इन द हेलो पैकेट। जीरो प्रायोरिटी, you can set the zero priority, the router will never participate in the DR video election। ये भी देख लो। R6 is right, not DR, right? Let's do one thing, interface 0/0, IPS for priority 0, so IPS of interface 0/0 क्या बन गया, DRO। once I define the priority 0, automatically this guy will become the DRO। previously it was DR, right? Previously it was DR because the priority is 100। now I define the priorities 0, automatically they say that I'm DRO। so if the priority defines the 0, they're not going to identify who will become the DR and BDR। so previously backup DR was 105, now the DR become the 105, now they are finding the who will become the BDR in this domain। हो गया। अब एक क्वेश्चन आता है, बहुत अच्छा क्वेश्चन बताता हूँ। दिस वन क्वेश्चन कम्स इन इंटरव्यू, नॉट इंटरव्यू, पता नहीं कहीं पूछ दे तुम लोग से। हु विल बिकम द फर्स्ट DR एंड BDR?
PDR।
अरे शानदार, कहां से खोज के लाया तू, जल्दी बता दे। व्हाई? व्हाई?
I don't know why।
इसका पता करके ना, व्हाई। फर्स्ट द BDR हैज इलेक्टेड इन योर डोमेन, देन DR। फाइंड द आंसर व्हाई। मुझे भी नहीं पता है, कल खोज के ना तब मुझे बता रहा तुम, ठीक है। एंड सॉरी फॉर टुडे।